Hello, I'm Bob McMaster. Welcome to another in a series of Zoomcasts on the life and legacy of Edward Hitchcock, this one entitled Edward Hitchcock and the Geology of Cape Cod and the Islands. Edward Hitchcock's name is most often associated with Western Massachusetts, where he lived, and with Amherst College, where he taught for nearly 40 years. But early in his life, he developed an interest in southeastern Massachusetts, and he became a pioneer in unraveling the geological history of Cape Cod and the islands. Our story begins in June of 1823 at Holmes Hole, the town we all know today as Vineyard Haven on the island of Martha's Vineyard. The packet boat from New Bedford had just arrived, filled with cargo, but also with a few passengers. One of them was a tall, gaunt figure. He was dressed in a black topcoat and a black stovepipe hat, and must have seemed out of place amidst the hustle and bustle at dockside, surrounded by fishermen hawking their wares and liverymen loading their wagons. That unlikely figure was the Reverend Edward Hitchcock, pastor of the Congregational Church in Conway, in western Massachusetts. He had dedicated his life to preaching the Word of God, to saving souls, but his mission on this spring day was not spiritual, it was geological. At Holmes Hole, Hitchcock hired a chaise, a horse-drawn carriage with a single seat, then set out to tour the vineyard. It probably turned more than a few heads, the sight of that austere figure trundling along the island's roads and rutted from Edgartown to West Tisbury to Chilmark and then back to Holmes Hole, stopping frequently along the way to survey the landscape and collect rock samples. As he traveled around the vineyard, Hitchcock observed three distinct geological zones shown on this map drawn by his wife, Ora White Hitchcock. To the south, he found a perfectly level sandy tract, uninhabited and uninhabitable, which he named the alluvial formation. On the western end of the island, he noted a second zone consisting of alternating beds of variously colored clays, sands, and pebbles that he termed the plastic clay formation, borrowing a term from British geology of his day. But the feature that most interested Hitchcock on that first trip to the vineyard lay atop the clay from Chilmark to Holmes Hole, what he referred to as the diluvial formation. He wrote, "All the northwestern extent of the island is hilly and uneven, with no abrupt precipices, but rising into rounded eminences, some reaching 300 or more feet above sea level. These loose stones vary in size, from that of the smallest pebbles to that of masses, 10 or even 15 feet in diameter. They were composed of granite, gneiss, quartz, and mica, and he named this the diluvial formation, the term diluvium in his day referring to material deposited by floodwaters." Most striking of all to Hitchcock on that first trip to the vineyard was the quantity of huge boulder stones scattered over those hills on every side, some over 50 feet in diameter. At first, he assumed these to be outcrops of the underlying bedrock. But the local inhabitants soon set him straight. There was, they assured him, no bedrock to be found anywhere on the island of Martha's Vineyard. About 7 months later, in June of 1824, Hitchcock's article appeared in the American Journal of Science. It was the first detailed geological study of the vineyard ever to appear in print. In that article, Hitchcock addressed the matter of those huge boulders. If they were not derived from the underlying bedrock, where had they come from? Here, Hitchcock made a telling observation, one that would resonate among geologists worldwide over the coming decades. Those boulders, that diluvium, he asserted, must have been derived from the rocks that occur in place along the coast on the mainland. There it was, a hint of what was to come, a revolution in our understanding of the forces that shaped much of this continent. Near the end of the same article, Hitchcock made yet another point with profound implications. Those three formations he observed on Martha's Vineyard were not limited to the Vineyard. He wrote, "The Vineyard and Nantucket are a continuation of the extensive formation hitherto called alluvial, of which Long Island has been regarded as the northeastern limit. If we prolong this curve still further, it will include within it Nova Scotia and at least part of Newfoundland." We can see that Hitchcock was taking his observations from that brief trip to the Vineyard and drawing a larger inference about all of North American coast, all of the North Atlantic coast of North America. Of course, that observation raised the question, what force was responsible for this 1,000-mile-long accumulation of sand, silt, gravel, and boulders? And for that, he referred back to the diluvium. Edward Hitchcock, like most scientists of his time, regarded much of the surface geology of the Earth as the result of a flood, the great flood of Genesis, the flood of Noah and his ark. So when he assigned the label diluvium to the detritus covering the northwestern portion of Martha's Vineyard, he was ascribing its deposition to that great biblical cataclysm, a conclusion with which most geologists of his day concurred. Now, Edward Hitchcock was a man of strict Orthodox Christian faith and ill-inclined to trifle with God's word. But he was also an astute observer and thinker, particularly on matters geological. And that mixture of pebbles and stones, all apparently transported from the north and west, it clearly troubled him. And those huge boulders, some weighing 100 tons or more, what flood, however powerful, could move one of those, he asked, and why would a flood carry all that material in one direction rather than dispersing it randomly over the sea bottom? In time, those questions would lead him to a stunning conclusion, one that would overturn many long-held beliefs, both scientific and religious. 7 years later, Edward Hitchcock returned to southeastern Massachusetts, no longer as a church pastor, but now as professor of chemistry and natural history at Amherst College, a position to which he had been named in 1825. He had received an appointment from Governor Levi Lincoln as the first state geologist of Massachusetts. His assignment, to carry out a detailed geological survey of the Commonwealth, the main purpose of which would be to identify some of the state's untapped mineral resources. This was a massive undertaking over 4 field seasons. Between 1830 and 1833, Hitchcock would travel some 2,000 miles, visit every corner of the Bay State, gathering rock and mineral specimens, taking voluminous notes, and making sketches of the rocks and rock formations he observed. He set out from Amherst on July 30th, 1830, on the first field excursion of the survey, traveling in a rickety horse-drawn wagon accompanied by one of his students. What you see here is the route of his second excursion of that summer, beginning near the end of August, that would take him to southeastern Massachusetts and Cape Cod. This is a page from Hitchcock's field notes on the day he and his assistant first arrived on Cape Cod. And I should mention here that my Hitchcock research would never have been possible had it not been for the enormous collection of Hitchcock's unpublished, handwritten field notes, letters, and sermons preserved in the archives and special collections of Amherst College. Not surprisingly, Hitchcock's first observation of the Cape harked back to his visit to the Vineyard 7 years earlier. From Sandwich to Barnstable, 12 miles, diluvium all the way. In many places, the boulders are enormously large, weighing 100 to 200 tons, and very short, very thick. In short, the face of the country and its geological character appear to be precisely like those of Martha's Vineyard and the Elizabeth Islands. I doubt not, but the same remark will apply to the whole of Cape Cod. Some of Hitchcock's notes from that first foray to Cape Cod read more like the random musings of a tourist than the methodical observations of a scientist. He wrote, "The roads are not as bad as we expected to find them. The scenery, made up of sand hills, marshes, salt works, and here and there a copse of low trees, is picturesque, though generally dreary. The houses appear better than we had anticipated, and there is an appearance of comfort and even thrift, which we had not expected. The inhabitants also appear obliging and civil everywhere." As he traveled through Barnstable, Yarmouth, Dennis, and Brewster, Hitchcock observed salt works, salt marshes, and peatlands or bogs. Cranberry cultivation on man-made bogs had barely begun at that time, so most of the peatlands Hitchcock saw were naturally occurring peatlands, such as are still found in some places on the Lower Cape, Nantucket, the Vineyard, along the coast of Maine, and in maritime Canada. He wrote, "Peat is very abundant in almost every town on the Cape, and white cedar swamps. Hitherto it has not been much dug, but we perceive the inhabitants frequently getting it out. It must prove an invaluable treasure." And in his final report in 1833, he wrote, "I cannot but regard the existence of so large quantities of peat on Cape Cod and Nantucket as a great blessing to the inhabitants." Hitchcock reserved his most effusive descriptions of the Cape's scenery for its outermost extremity. He wrote, "Truro exhibits the most remarkable example of diluvial action that I ever saw. The whole town is scooped out and piled up in that peculiar manner which characterizes diluvium, the hills being from 1 to 200 feet high and often very steep." Still farther up the arm of the Cape, he made this observation: "The appearance of Provincetown is exceedingly picturesque. As we ride along the beach below the houses, first stand the windmills, then the houses in irregular order, generally 2 or 3 rows, and mixed with yards for drying fish and salt works. A semicircular bay is enclosed on the north and east by a sandy beach and low sand hills almost destitute of vegetation, which seem to threaten, and do in fact threaten, to bury the village and to fill the harbor." Hitchcock was so enamored of Provincetown that he offered an accolade that many modern-day visitors would likely endorse. He wrote, "A visit to Provincetown by land would probably, in most cases, be quite as effectual a remedy for ennui and other fashionable complaints as a resort to Ballston and Saratoga." Wouldn't he be pleased to know that today, 2 centuries later, Provincetown continues to be an effectual remedy for ennui and other fashionable complaints? Traveling south once again, Hitchcock described an odd sensation that he termed a mirage, an experience I recall from childhood vacations on Cape Cod long ago. He said, "A curious deception was noticed by myself and 2 companions in the sandy regions of the Cape, particularly in Orleans. We seem, even on level ground, to be ascending, in other words, to be placed in a basin. We observed this mirage so frequently, and it was so striking, that it could not have been a mistake. Frequently the road seemed to have an ascent of 2 or 3 degrees before us, and on passing forward and looking back, an elevation equally great appeared in that direction. This phenomenon seems to be of the nature of what the sailors call looming, but I cannot explain it, and especially why it should appear in a sandy rather than any other region." Well, Hitchcock's description of that mirage may have been the first ever to appear in print, but it would not be the last. Some 30 years later, another astute observer of the natural world, Henry David Thoreau, wrote of a similar experience in his famous essay, Cape Cod, even mentioning Hitchcock's earlier observations. "On our way thither, we had occasion to admire various beautiful forms and colors of the sand, and we noticed an interesting mirage, which I have since found that Hitchcock also observed on the sands of the Cape." Hitchcock was not surprised to find many huge boulders on the Cape, not unlike those he had seen on the Vineyard. Boulders such as this one at Tonsett, at Doan's Rock in Eastham, and on the right, the boulder I remember climbing on long ago on the shores of Cliff Pond in Brewster. At Falmouth, Hitchcock boarded a steamer, intent on studying the Gayhead Cliffs in the town we know of today as Aquina. For what he witnessed on that excursion, he spared no superlatives. "The most interesting spot on the Vineyard," he wrote, "is Gay Head, which constitutes the western extremity of this island, and consists of clays and sands of various colors. Its height cannot be more than 150 feet, yet its variegated aspect and the richness of its colors render it a striking and even splendid object when seen from the ocean, Every lover of natural scenery would be delighted to visit this spot. There is nothing to compare with it in New England. Back on the mainland, Hitchcock traveled north of the Cape. Again, he was perplexed by the many huge boulders scattered over that sandy peninsula. He wrote, "From Falmouth to Plymouth, 36 miles, diluvium all the way. But in the west part of Falmouth and Sandwich, the boulders are so large and thick and so numerous, and the hills so high, that there can be no doubt that granite and gneiss are in place a little below the surface." And when he says in place, he means in the bedrock. In his 1833 report, Hitchcock reiterated his belief that the boulders of Cape Cod were derived from bedrock not far below the surface, and his geological map for that report indicated as such. Nevertheless, he seemed to leave the subject open to further discussion. "The map will show," he wrote, "that I have extended a strip of granite from Plymouth into Barnstable County as far east as Brewster, and carried another branch into Falmouth. Others must judge whether the evidence of the existence of granite in place in the region under consideration is probable enough to justify me in the course I have taken." And I have highlighted that area in blue. But in his 1841 revision of that map, the granite bedrock of Cape Cod has been removed. In his explanation, he hedged a bit on the question. He wrote, "As the entire surface is diluvium, I thought it better to color it as such, thus representing what I know exists there, instead of something about which I am not certain." Well, Hitchcock may be forgiven his equivocation on this point. Not until the mid-20th century would the matter be resolved, when geophysicists determined that the depth of the bedrock ranged from 80 feet at the Cape Cod Canal to over 1,600 feet below the surface at Nantucket. A map from that study shows the highest elevation of the bedrock extending from Bourne to Barnstable and southward to Falmouth, as I've highlighted in blue, comparing very favorably with Hitchcock's map of more than a century earlier. Hitchcock received yet another hint about the region's geological history in his travels to the Cape and Islands in 1832. He wrote, "A pilot told me that on the west side of the harbor, that was Holmes Hole, he had seen what looked like a swamp or marsh, and another man said he believed some cedar swamps had been found formerly toward the lighthouse in shallow water. Mr. Allen Chilmark tells me that cedar stumps have been found on the northwest shore of the Vineyard near Gay Head." He received similar reports of tree stumps in shallow water from Nantucket, Yarmouth, and elsewhere along the Atlantic coastline. Those submarine forests, as he called them, are still to be found and have attracted scientists right up to the present. These here are images from a 2014 study of a paleo forest of 111 cedar trees that can be seen at South Cape Beach in Mashpee at very low tides. They are regarded today as evidence of sea level rise in the last 10,000 years, due at least in part to the melting of polar ice. In his 1833 report, Hitchcock wrote, "Geologists are not a little perplexed satisfactorily to account for submarine forests. In general, it has been supposed that these forests have subsided in consequence of earthquakes or other internal movements of the earth." Hitchcock seems to have accepted the idea that those submarine forests had once stood on higher ground well above sea level before the land subsided and the trees were inundated with seawater. It is doubtful that he ever contemplated another explanation for that phenomenon, rising sea level from glacial meltwater. But in 1833, the idea that a vast glacier once covered most of New England was stuff of science fiction, and to Professor Edward Hitchcock, but not for long. Also on the mainland, Hitchcock observed two other important geological features that further reinforce his doubts about the origin of that so-called diluvium. Gouged in bedrock across New England, he noted deep furrows, nearly all with the same orientation, from northwest to southeast. In addition, he observed sinuous strains of large boulders, many extending tens of miles from their origin, all with similar orientations. Here we see the probable path of Doan's Rock and a boulder at Gay Head from a publication a century later. but the arrow on the left depicts what may have been the first documented boulder train, one that was discovered and first described by Hitchcock in that 1833 report. It's a train of magnetic ore extending some 30 miles the full length of Rhode Island, from Cumberland on the north all the way to Newport on the south. The report of Edward Hitchcock's Geological Survey was published in 1833, and it was a landmark in American geology, the first comprehensive geological survey of any state. It was surprisingly popular considering its length, over 700 pages. His report and his survey became models that nearly 24 other states replicated over the next 20 or so years. In the early 20th century, George Perkins Merrill, curator of geology of the National Museum of Natural History in Washington, D.C., known today as the Smithsonian, wrote that Hitchcock's report marked an epoch in American geological work. By now, Hitchcock had seen more than enough evidence to make him skeptical of the diluvial hypothesis, that notion that the great flood of Genesis was the force responsible for most of the sculpting of the Earth's surface. In his report, he wrote, "Making every allowance for the reduction of the gravity of these boulders when in water, I confess I cannot conceive how such a work could have been effected by this agency," that is, by water. But what were those agencies? That question continued to bedevil Hitchcock. Then, in 1841, he received a copy of a geological treatise entitled Études sur les glaciers. The author was a Swiss scientist named Louis Agassiz. Agassiz put forward the radical notion that ice, not water, was the primary agent responsible for sculpting much of the surface of the northern hemisphere, that a huge ice cap had accumulated in the northern polar regions, gradually expanding southward over hundreds of thousands of years. It was a glacier or a series of glaciers of massive extent, and it gouged, scraped, and bulldozed the Earth's surface as it advanced. One side note here, some recent research suggests that much of Agassiz's work on glaciers had been adapted without credit from the writings of this man, German-Swiss geologist Jean de Charpentier, and others. When Edward Hitchcock read Agassiz's treatise, he was an immediate convert. In an address to the Association of American Geologists at the Academy of Natural Sciences in Philadelphia in April of 1841, he described the theory of the glacial origins of those effects with evangelical fervor. While reading this work, he said, I seem to be acquiring a new geological sense, and I took a look upon our smooth and striated rocks, our accumulations of gravel, and the tout ensemble of diluvial phenomena with new eyes. Hitchcock's ringing endorsement gave the theory of continental glaciation wide exposure and credibility among American scientists, although there remained a good deal of resistance in some quarters. Hitchcock himself backpedaled and equivocated on the idea repeatedly, but the evidence was strong and compelling. By the 1860s, that theory had been accepted and embraced by most scientists in America and worldwide. As to non-scientists, particularly theologians, members of the clergy, and other people of faith who were suspicious of new ideas in science, the fact that Reverend Edward Hitchcock, well known as a devout man of strict Orthodox Christian views, was comfortable with such a notion may well have given them license to accept the theory. In his revised published report later in the same year as that speech, 1841, Hitchcock brought these new revelations back to those visits to Cape Cod and Martha's Vineyard when he wrote, "Is it possible that the whole of Cape Cod is nothing but a vast terminal moraine produced by a glacier advancing through Massachusetts Bay and scooping out the materials that now form the Cape?" While it was still an idea that was struggling to gain converts, it is clear that Edward Hitchcock was the first scientist to place Cape Cod and the islands in the context of continental glaciation. Edward Hitchcock's life was a dual journey of faith in God and faith in science. It led him to question some of the basic tenets of his religion, as well as some of the fundament of those huge boulders scattered over a sandy chill-marked plain. It was reinforced by subsequent visits to the Cape and the islands in 1830 and 1832. In a sermon delivered to his congregation in January 1823, just a few months before that first trip to Martha's Vineyard, Hitchcock warned his parishioners to pay heed to the world around him. He said, "Let the unbeliever then remember that as he passes over our hills, the very stones cry out against him." Well, the boulders did cry out to Edward Hitchcock that day on Martha's Vineyard, and the message they bore was truly a revelation in stone. For more information on Edward Hitchcock, I invite you to read my book, All the Light Here Comes from Above, The Life and Legacy of Edward Hitchcock. You might also be interested in visiting my website, www.edwardhitchcock.com, where you'll find more information on the book and on the man. On my YouTube channel, you will find a number of other short videos on the life and legacy of Edward Hitchcock. Thanks very much for joining me today.